All right, I think we should just start now. Professor Shoma, should we wait for 2 minutes or should we just start?
Ma'am, you're on mute.
Sorry. No, I was saying that she's already in advanced time. Ma'am, what's the difference? 3.5 hours?
2.5 hours.
2.5, yes. So
your working day is already over.
Yes, so we can start.
I think we should start, yeah. All right. So Neeraj, could you present the bouquet, please? Neeraj?
He started the recording.
Yeah, so we have a digital online bouquet for you, welcoming you, Dr. Shweta.
Thank you.
All right. Neeraj, if you could get that off, please. All right. So I have great pleasure in welcoming Dr. Shweta Pandey to briefly talk about her career. She has, in the earlier part of her career, worked with GE Money Financial Services, and then she was also vice president at GE Capital Business Management Services Limited. She has been teaching earlier at Loyola Institute of Business Administration, Chennai. She has also taught at De La Salle University, Manila, Philippines, and is now currently teaching at National Taiwan University, Taipei. Her areas of interest in teaching are in the fields of consumer behavior, digital marketing, marketing research, and marketing strategy. She has published more than 15 research papers in reputed journals. She also has case studies published in Ivy Case publications and a few book chapters to her credit. Shweta, let me know if I missed out something, but I thought I'll Okay, so today I invite her for this session on applying research techniques to marketing. She has, as you can see, a lot of experience in teaching these subjects and also has done a lot of research papers. So I think we're going to learn a lot from her. All right. So students, can we all have you on mute, and can we all have your cameras on, please? Yeah. Okay. Over to Dr. Shweta. Yes, please.
Thank you, Dr. Nija, for a very warm welcome. Good afternoon, everybody. Back in India, I do miss India a lot, and I wish I was there as well. Okay, so I'll just put on my slides here. All right. So today I'm going to talk about applying research techniques to marketing. And research to me is basically looking at what everybody else has seen, and then to figure out things what they have not thought of. And I'll elaborate that a bit as I proceed through the session. So we all have a lot of everyday questions, things like, what will make a 15-year-old buy a load of INR 100, or whether I should invest in a particular product, or which products sell best at night, right? So many of these everyday questions, and one way to get an answer is to look at marketing research and figure out whether what will be the answers for these. So research techniques pretty much are not really about just marketing or customer relationship management. They can be applied to any function of the business, including human resources, finance, and pretty much any kind of function in a business. And it's not just only statistics that you learn in research techniques. There's a lot of critical thinking, a lot of analysis, a lot of understanding of the story behind the entire data. And research is not necessarily everything about big data. So to say, all of us talk a lot about big data, but it can be done at a small scale. And it is a very nice way to understand, reasons why things happen the way they do, and requires a lot of clear thinking and decision making as well, along with a lot of statistics when you apply those techniques. In a way, it kind of, with research, what you do is you collect data from the market and convert it into an information for the business, so that the business can take relevant actions to, reach out to the market. So let's talk about research for marketing. And research for marketing kind of spans a very big area. Starting with when you look at a marketing plan, you talk about target markets. So to start with, research in marketing applies, techniques like cluster analysis for segmentation studies. It is also used for doing satisfaction surveys with customers to understand what factors will improve their satisfaction. It applies to all the 4 P's of marketing, whether it is product, in terms of understanding how to position your product, what kind of brand preferences your consumers have. It is also used for things like understanding your distribution network and which store site to select. It is used for promotion a lot, where you do a lot of experimental research for understanding what kind of advertising works well for a particular customer. It is also used a lot in pricing of your products, where you look at things like price elasticity analysis to understand what is the optimum price that you should offer your product to in the market. And then it is also used for things like, company brand management, reputation, understanding how can, all the consumers perceive your company image, etc. So today we will talk about 2 techniques. One of them is exploratory factor analysis. Exploratory factor analysis basically is undertaken, without any kind of hypothesis in mind, which means you don't really need to say, oh, this variable impacts this variable. You just have a lot of data. And what you're trying to do with that entire data is to understand whether there is any association which exists between these various variables on which you have a data, and whether these entire set of variables can be clubbed down into smaller groups. So let's talk a little bit more about what I mean by that. So I call it the problem of plenty. And what I mean by problem of plenty is, suppose you were a marketer and you did a survey for customer satisfaction. Now, there are many reasons or many variables which may impact a customer's satisfaction. So as a marketer, you want to capture everything in your survey, right? But when you have too many of these variables, too much of this data, sometimes it's very difficult to understand what are the broad factors which will impact your end customer satisfaction, because you have like 30 variables on which you've collected data. So if somebody asks you, out of those 30 variables, what are the top 3 broad areas which will impact your customer satisfaction, you sometimes are at a loss. And therefore, is there a particular process where we can reduce this data to a little more manageable level, and do that without kind of losing the entire essence of each of the variables on which you have collected the data? So you do that by this technique of factor analysis, where you kind of club data points or variables into groups based on how correlated they are. Let's take an example here. Suppose you have this factor analysis to be done on ratings of a fast food restaurant, and we have here data of about 7 consumers. So we see that while I'm showing you only 6 factors or 6 variables here, like waiting time or cleanliness, etc., there may be many more such variables. And when I say what is these data points are nothing but if you do a survey and you take a 7-point Likert scale from whether this factor impacts their satisfaction, strongly agreed to a strongly disagreed on a 7-point scale, then these are the ratings which a consumer has given on those particular variables. So for a consumer A, they've given a rating of 2, 2, and 1 to waiting time, cleanliness, and personnel, and a higher rating to food taste, food temperature, etc. Now, a broad look at this entire data shows that these variables here, which is waiting time, cleanliness, and personnel, have got similar kind of ratings across these consumers. However, you have these 3 variables, which is food taste, temperature, etc., which have a very different kind of rating. So broadly, you know that these 3 variables here kind of correlate well with each other, whereas X4, X5, and X6 are correlated better together. And that's the essence of factor analysis, of how we do factor analysis. So when you run the technique, the data will be divided into 2 factors. One factor which will constitute of X1 to X3, and one factor which will constitute of X4 to X6. And we name these particular factors based on what kind of variables are showing in that factor. For example, here things like waiting time, cleanliness, personnel, more like service quality. And here we have food taste, temperature, and freshness, which is all related to food quality. So what this technique has done is it has collapsed those variables into smaller set of variables. So what this technique is doing is it's dividing many variables into fewer groups. And it does a lot of data reduction, and all of this data reduction is happening based on the correlations between these variables. Also, this technique accounts for the variation in several original variables. So it kind of puts them into a smaller number of artificial factors, which we have named as service quality and food quality. This technique is also known as dimension reduction. So what we got over here are factors which are nothing but they are linear combinations of these variables. So factor 1 here is a linear combination of X1, X2, and X3. And this is the way it can be written from a mathematical standpoint, which is, the first factor will be an equation that you will write, where you will say that factor 1 is a function of X1, X2, and X3. Similarly, for factor 2, mathematically, it will be written as factor 2 is the function of X4, X5, and X6. That's what factor analysis broadly does for your entire data. So what is a factor? Factor is nothing but it's like a unobserved hidden variable, which affects several observed variables. So like in your data, we had all these observed variables, X1, X2, X3, X4, X5, X6. Now, when we clubbed it into 2 factors, these 2 factors were like not really data on which we gathered, data from our survey, but these are hidden factors which affect these these 6 variables. And these factors will account for correlations between these variables. So factor 1 will account for correlation between variable A, B, and C. Similarly, factor 2 will account for the entire correlation between variable D, E, and F. So these are like the underlying causes which are impacting these variables. That's how you kind of interpret this entire factor. There are some conditions that you have to meet for doing factor analysis. First is that when you collect your data, you should have it either on an interval or ratio scale, which is broadly a Likert scale. You also need to have data which is standardized. So you cannot use factor analysis on 2 data sets wherein one data set has a Likert scale from 1 to 5 and another data set has a Likert scale on 1 to 7. So they have to be standardized together. And you can do that standardization, by simple way of, the normal standard deviation method. I'm not going into that method here, but if you have questions, I can explain that. And then the other thing you have to take over here, factor analysis requires a lot of data. So if you have, 5 variables, you at least need to have 5 times the number of data points. So you at least need 5 into 5, which is 25 data points for you to be having good enough data to proceed for factor analysis. Again, when you look at factor analysis and you are assuming that this data will be broken into, say, X or Y number of factors, when these factors somewhere these variables somewhere should be interrelated. They should not be from very, very different domains. For example, in the food example that I just showed, we had all the variables which were capturing things which are related to the food of a restaurant, not talking about, say, size of the dress or something like that, which is a completely unrelated variable. And that doesn't make sense from a factor analysis perspective. Any missing data should be also imputed through various techniques. Normally, a good factor analysis requires that you at least capture data on variables which are at least 4 to 6 variables per factor that you are expecting. So if you are having, say, a factor on service quality, you should at least capture in your survey 6 to 7 variables which relate to service quality. Then you will come out with a good factor analysis output. And we use packages like SPSS or Stata for doing factor analysis as a technique. Again, initial set of variables have to be highly correlated. For doing that, or for checking whether your data has correlated variables, you use something called as Bartlett's test of sphericity. Now, what this test really does is it is a statistic which is used to examine the hypothesis that the variables are uncorrelated. So your null hypothesis here basically says that your variables are uncorrelated, and your alternative hypothesis shows that they are correlated. So what we want as a result of checking this test is that the output statistic should be having a high value, and it should favor the rejection of null hypothesis. That means your test statistics should be significantly significant, right? Your p-value has to be significant. If the null hypothesis is not it is not rejected, then we say that Bartlett's test is not being useful, which means that we should not be going ahead with factor analysis in that particular scenario. The second test that we do over here is called the Kaiser-Meyer-Olkin measure for sampling adequacy. Now, it is in short form, we call it as KMO. Now, this statistic compares the magnitudes of observed correlation coefficients with magnitudes of partial correlation coefficients. And again, here you need to have values of this particular coefficient to be between 0.5 to 1 for factor analysis to be appropriate as a technique. We will definitely see how it is used through an example. Now, there are various steps when you do an exploratory factor analysis. First, you will obviously formulate the problem. You are trying, then you will put the data into the system to come out with the correlation matrix. You will have a method of factor analysis which you will choose. Sometimes you want to put in the number of factors you want from the data yourself. If you are already aware of how many factors you want, then you can put that number. Else, you can leave it for the system to calculate how many factors will come out of that data. Then you rotate the factors and interpret it. So let me go through the entire set of steps. For example, here I'm talking about a problem where there is a data collected from 80 individuals on investment behavior. And there is a lot of variables here, which is a score on risk averseness, returns, insurance cover, tax rebate, etc. We have collected this data from these individuals on a Likert scale of 1 to 5, 1 being strongly disagree to 5 being strongly agree. Now, what we do is all of this data across these respondents is entered into SPSS, and I'm showing you how the entire factor analysis works on SPSS. So here, first you will go to the Analyze tab, and then you go to Dimension Reduction. Because we are looking at factor analysis, it's a dimension reduction technique. So we will come over here, we'll say Dimension Reduction and click on Factor Analysis. Next, all this data will show as variables into your window. You will use the arrow to move it into the variables window. After all the variables move over here, they will start showing over here. Once they show over here, you will click on the Descriptives tab to select Univariate Descriptives, Initial Solution, and you will click on KMO and Bartlett's Test of Sphericity. Next, you basically click on and choose, you click on Extraction and you choose the Principal Components method, and you click on the display of unrotated factor solution and screen plot. Now, I will explain why we are doing all this, but just as an understanding. When we say principal component analysis will reduce your data into factors while preserving as much information as possible from the original data. And it will convert this set of variables into linear combinations. As we talked about, the linear combinations are basically the factors that will come through. And then we also do rotation of factors. Now, why do we do rotation of factors? We do that to make the solution very easy to interpret. And I will show you that particular output, which is before rotation and after rotation, for you to understand why we need to rotate the factors. Now, when we do rotation, all of this variance, which is explained by the factors taken together, remains the same after rotation. And one of the most common types of rotation that we use is called Varimax rotation. This rotation kind of maximizes the variance of the loadings within each factor. Okay, and let me show that to you so that you get to understand that better. So how do we do rotation? We click on this tab, which is rotation, and we can select over here different types of rotation. The most widely used rotation technique is called Varimax technique. So I've clicked on that. And then we go to options. Now in options, the output display, we want to make it as clean as possible. So we will say that show the factor loadings sorted by size, and say suppress small coefficients. So you do not want the unnecessary factor loadings, which are very small in size, to show in your output. And you can specify a value over here. I've put it as 0.5. It could be 0.4 or 0.3 as you want, right? And then you can also save this factor scores. What is a factor score? Is basically this score which will come out. These are like composite scores for each respondent. So for each respondent, that respondent's data is converted into the factor scores, which is a composite score. And factor scores have a property that they are independent variables. And they can be used in other techniques. I'll talk about that as well, right? So this is an output that you will see over here. So once I put all of that data, this is the first output screen that will show, which will show you the output of KMO and Bartlett's test. Now in this case, the KMO measure is greater than 0.5. So we will interpret it as it is okay to conduct factor analysis. Similarly, Bartlett's test of sphericity is significant. The p-value is less than 0.05. So we can proceed with the factor analysis. Now, factor analysis output matrix will show like this. Okay. So this is a component matrix which shows the output of your factors. So the data has been divided into two factors, and these are the factor loadings. Now over here you see that you have one particular variable which is loading on both factors, right? That means it is linked to correlated to both factors, right? Which is very difficult then for us to interpret. And therefore, we need rotated component matrix, because rotated component matrix will try and move or clear out that entire component matrix so that you exactly know which variable to associate largely with which factor. Okay, so this is what it does. It tries and clears out your thing and makes sure that each variable is linked to largely to one factor. Now, what are these two factors? Now, we name these factors. The system does not name the factors. It will just say that these are the two factors which have come out. We name these factors depending on which kind of variables were showing a very high correlation with that factor. So something like easy accessibility and maturity time, we have named this factor as perceived value of a service. And things like insurance cover and risk averseness, which is your second factor, is named as security. Now, this naming is something which you do on your own as you interpret based on the variables which are there and loading maximum on that factor. So what are these factor loadings? Now, these factor loadings are nothing but just the correlation. So what is the correlation between easy accessibility and this factor? This is the correlation. That's how you read these factor loadings, right? These are just correlation values. Okay. Then you will get something as an output, which is called Eigen Value. Okay. Which will show here at the bottom. Now, what is this Eigen Value? Now, this eigenvalue, it kind of shows the amount of variance that this factor kind of explains for the entire data, right? If a factor solution has an eigenvalue of 1 greater than 1, it means it explains more variance than a single observed variable, which means this factor explains the entire variance of the data better than any of these single variables, right? And how do you calculate this eigenvalue? This is nothing but the square of all these loadings. The sum of squares of all these loadings, this will come to be greater than 1. For a factor solution to be correct, this, for a factor to be a relevant factor for you to assume, this eigenvalue has to be always greater than 1. It cannot be less than 1. If it is less than 1, that means your factor solution hasn't come out correctly. And why it has to be greater than 1 is because it has to explain more variance than any of these individual variables. Right? So in our solution, we found that there are 2 factors because there are 2 factors which are showing an eigenvalue greater than 1. Right? And what is this? This is the percentage of variance of the total data which is being explained by factor 1. And this is the percentage of variance which is explained by factor 2. Another way to understand how many factors are there in the data is to look at the eigenvalue scree plot. Now this plot will also show in the output. And in this plot, wherever this particular graph is bending, it has this elbow or a king. That are the number of factors which are there in this particular factor solution. So we see over here, while there may be 6 or more overall factors showing, but the curve is bending over here. That means this particular data, it can be broadly divided only into 2 key factors, which is what our output also showed, right? Now, one more thing which comes out in the particular output is called communality. Now, what is communality? It basically is a measure of how much variance of the variables is explained by all the factors which are there. So if I did this factor analysis and I have 2 factors, what is the total percentage of this particular variable which has been explained by factor 1 and 2? So for example, over here, the score of risk averseness, 59.8% of the variance of this particular variable is being explained by all the factors of our solution, which is factor 1 plus factor 2 together account for 59.8% of the variation in this particular variable. Right? And how does the system calculate communality? It is nothing but for each variable, it is the sum of squares of the loadings across these factors. So for easy accessibility, you had a loading of 0.793 on factor 1 and 0.047 on factor 2. If you square them and you sum it, you will get the total communality. Okay. Right. So this is the final output, which we talked about. Now, just to revise everything, what are the statistics associated with factor analysis? You have factor loadings, which are just the simple correlation between the variables and the factor. The factor matrix is nothing but the component and the rotated component matrix that we saw. It contains all the factor loadings of all the variables on the factors. And then you come out with factor scores. What are factor scores? As we talked earlier, this is a composite score which is estimated for each respondent on the factors, right? It's kind of a numerical measure which in a nutshell will describe how strongly a variable from the data that you collected is related to this factor that we have calculated, right? And what is communality? It's the proportion of variances for the variable, which is explained by all the factors which are coming out in our solution. Okay, let's go forward with this. Now, where do we use factor analysis? Now, this is a very important area for you to understand. The steps of SPSS can always be learned, and Dr. Nija can always help you look through them. But what is important for you is to understand, why do we need factor analysis at all, and where is it used in terms of marketing and other techniques. So to make the data manageable, when you do something like a market segmentation, right, you may have a lot of factors or a lot of variables on what you are segmenting your data. Now, when you run the entire segmentation analysis, if you have 30 variables on which to segment your market, when you get the output, it will be very difficult for you to interpret. So what you do is you first, kind of condense that all those variables into key broad factors, and then you use the factor scores from that data into your segmentation analysis, which makes the entire interpretation much more easier to do. Factor analysis is also used in product research. For example, if you're looking at what are the brand attributes which influence a consumer choice, then companies will have a lot of attributes on which they will collect data using surveys. And then they will condense these attributes into broad factors, which will then be used for their interpretation of what are the broad factors which will impact, which are consumer perception. It's also used in advertising studies to understand media consumption habits of your target market, and in pricing studies to identify characteristics of, say, price-sensitive consumers. These are some examples that I've put through. It's also used a lot in consumer profiling. For example, if you've read in marketing, there are various kind of personality traits of a consumer, and to measure every trait and put each and every trait as a separate variable into your research will make it very difficult for you to kind of understand your data. So you will collect data on all attributes, but then you will condense them into broad factors, which you will then use to interpret your data. Similarly, lifestyles. Lifestyles are nothing but the activities, interests, and opinions of consumers. And there can be many items that you use in the survey to understand lifestyles. But it's very difficult to straight away interpret that data. So you will condense those items into broad factors. And then you will draw a psychographic profile of the consumer. It's also used a lot in perceptual mapping, which is positioning studies, where you try and see on what two broad big factors, how are the various companies in the market really positioned on, say, two big factors based on which consumers, interpret whether they want to be taking the products of that company or not. Again, a lot of loyalty related studies are using factor analysis, where you might want to distinguish which factors, discriminate between loyal customers and disloyal customers. And a lot of those data points are used to, for companies when they're doing a, customer lifetime value analysis and trying to give, say, better offers for loyal customers versus disloyal customers. Right? Again, factor scores can also be used because factor scores in the output are independent variables. So sometimes they are used in regression studies because they can help the researcher overcome the problem of multicollinearity. When you have multicollinearity in a regression equation, you cannot interpret the solution well because a lot of those singular variables are very correlated to each other. So what factor analysis does it collapses those highly interconnected variables into broad factors, and you convert them into factor scores which become independent from each other. So you can easily use it for a regression study later on. Now, here's an example of how I used factor analysis for one of my studies, which was on online customer experience in clothing e-retail. And I had collected this data from India. So my model basically here was that there are these various, almost like 6 + 4, 10 big factors which impact customer satisfaction and loyalty of online shopping buyers. However, each of these particular dimensions had at least 3 to 4 survey items related to it, right? Now, if I were to put all the survey items, I would have had almost 60 variables here with which I would have tried to do a regression, which would be an impossible task to do because there'll be an issue of multicollinearity, etc., etc. So what I did was I used all these statements, and these are statements which are kind of derived from literature, and I asked customers their agreement on these particular statements. For example, something like e-self inefficacy, I asked them things like whether they find internet ordering process hard, they do not know much about shopping on internet, or they are confident about shopping online without any help, So when you say something like e-distrust, whether they trust the entire shopping mode at all or not. Now, you cannot simply measure that trust or distrust with a single item in a survey, because that will not really give you what do you mean by distrust. And therefore, you have to use these multiple statements to understand from the consumer what does he or she feel when he thinks about distrust. So it has things like, I don't want to share my personal details, or I don't want to share my financial details. Now, these are two very different statements. Or I'm just very afraid on buying on the internet. Again, these are statements which are, again, related to negative beliefs about purchasing online or logistic ease, etc. So there needs to be these multiple statements that you need to really ask a consumer for you to figure out what they really mean by this particular factor. And so I took all this data in. Similarly, for website quality, I asked them multiple questions for each of the broad dimensions that I was trying to figure out. Things like interactivity, if you see, it says, I feel the website responds well, or makes purchase recommendations, or sends me promotions which are customized to my needs, or lets me see other consumers' opinions and relevant to my needs. So each of these statements you see are very, very different statements, but they're highly interrelated, right? And they kind of try and help us assess the same broad factor here, right? So there was like 60 to 70 such statements on which we collected data. Now, I can't directly put those 60 to 70 statements in my model. So these are just the explanation of the variables. So I ran that entire factor analysis and condensed that data into factors, and then ran my all my regression or my modeling. I use structural equation modeling. So I ran after that. But first I had to do an exploratory factor analysis for me to be able to really run that entire model. Okay. So I'll take a short break over here from speaking, and I want to see if you guys have any questions, then please ask me.
Yeah, I think Dr. Atul. Dr. Atul, if you need to ask a question, please. Okay. All right. I think, Shweta, if you want, you can just continue because maybe he'll ask.
Okay. All right. Any of the students have any questions? No? Okay.
I have a
Yes,
question.
ma'am.
Yes.
Charu, go ahead.
Thank you. I was just about to ask, can you show us that model and elaborate a little bit on the work that you did on the online space in clothing retail? Yeah.
Yeah. So basically, what I was trying to talk over here was this was a model on online customer experience and how that impacts the satisfaction and loyalty of consumers who purchase clothes on the online e-commerce sites. Now, based on the literature, I figured out there are certain psychological dimensions which impact their satisfaction, and there are certain functional dimensions, which is how good is the website in terms of interactivity, in terms of the information it gives, or how visually appealing it is, or how easy it is for the consumer to move on that entire website. And then psychological dimensions is our own beliefs about online shopping for clothes, because some people may have things like, logistically, if the dress doesn't fit me, then I will have to return it, and that's a big hassle, right? So I wanted to also look at those kind of beliefs which stop a consumer from purchasing online, right? Now, all of this data, this is just a model in terms of a visual model, but I had to collect data on each of these particular factors and then run my modeling, right? Now, each of these particular broad factors the data needs to be collected using multiple statements, right? Because you cannot just put one statement and say, this is what logistic ease means, because what it means to you may differ from what it means to somebody else. And that's why we use multiple different statements to understand broadly which of those statements really relate to a large percentage of your consumer base, right? So when I say logistic ease, what does it really mean? When I put that data, now I will collect the data and then I have to condense that back into these broad factors, right? Sometimes when you do that entire factor analysis, some of these statements may actually get eliminated in the factor loading. Okay, you remove them because they don't load well on the factor, right? Which helps you to understand which of these 7 statements or 6 statements that I asked the consumer, out of that, which are the top 3 or 4 statements which really impact a large percentage of my consumers. And therefore, it helps you to kind of, end of the day, define these factors in a very clear sense. So when I mean e-distrust, what exactly does e-distrust mean for my consumer? Does that clarify?
Yeah, thank you. If I may ask one more thing.
Yes.
You showed us the applications of factor analysis, and then I just want to understand how we tackle the problem of multicollinearity in the factor analysis.
Okay, when you run factor analysis and you save the factor output as factor scores, then these factor scores are independent variables. They do not correlate to each other. So factor 1 score and factor 2 score will be independent of each other, right? And therefore, when you use that in regression, multicollinearity will not happen, because multicollinearity only happens when those variables are highly correlated with each other.
Thank you so much.
Sure. Any other questions?
Yes, ma'am. I wanted to ask, you were talking about standardization of scales under the heading of condition for factor analysis. So I had a little difficulty in understanding that. It would be great if you could tell a little more about it.
Okay. Let me go back to that slide. Okay. So what you mean over here is that suppose I have collected my data on a 7-point Likert scale, whereas somebody else has collected a data on 5-point Likert scale. Now, we cannot simply use factor analysis on the data by just adding the data and, running the factor analysis. You have to use one kind of scale. So either I convert my 5-point scale into a 7-point scale, or you convert the 7-point scale into a 5-point scale, right? How you do that is, now it's difficult to show it over here, but what you do is you take the value for each respondent on that variable. You will take that, you will calculate for that variable the mean of that variable across respondents and the standard deviation of that particular variable. And you will, convert each of the value from the actual value to actual minus mean by standard deviation. And then you will multiply it by what kind of scale that you want to convert it in. So if you want to convert it into a 5-point scale, you will multiply that value by 5. If you want to convert it into a 7-point scale, you will multiply it by 7, right? That's how standardization is really done. Basically, you are trying to move the value from, say, a base of 5 to a base of 7 or vice versa. So all you have to do is you have to look at that variable, calculate the mean and standard deviation, and then for each of the data points, you reduce, you look at the raw score, you reduce the mean and divide by standard deviation, and then you multiply it by the scale level you want to convert it into. So if you want to convert it into a 7, you will multiply by 7. It's just a very simple statistical way of doing it.
Okay.
Yeah, if I can come in there. Yeah, Aditi, it's something like calculating your Z scores, beta, like X minus mu by sigma. That's
Yeah, ma'am. I could.
yeah.
Okay.
Yeah.
Let me just go forward with the. Any other questions?
Yeah, this is Professor Gaurav Sareen.
Yes.
Yeah, my question is, what's the difference between linear discriminant analysis and principal component analysis and factor analysis?
That's a very different discussion over here. Discriminant analysis, okay. You said linear discriminant, factor analysis, and principal component analysis. Okay, principal component analysis is a technique which is used to do factor analysis. It's used to convert your data into factor scores. What that technique really does, it tries to assign the maximum variance for the first factor and then the remaining variance for the remaining factors. That's broadly how it works mathematically. Linear discriminant analysis, I have not really worked upon, so I don't think I should be talking about that.
No problem. All right. Thank you.
So, Professor Gaurav, if you mean discriminant analysis and did you mean discriminant analysis?
Okay.
And regression or something?
Yeah, linear discriminant analysis, principal component.
Okay. Discriminant analysis.
So discriminant. Yeah.
So what discriminant analysis does, it's like what you do is you are trying to figure out that if I divide my data into two broad groups, then which of these variables that I have will help me kind of significantly understand that this data will be in this group or that group. For example, you have a set of data on loyal customers and disloyal customers. So you have a loyalty score for them. So what you do is using the loyalty score, you will broadly divide the data into two groups, loyal and disloyal, depending on if they are, say, 1 to 3 on the loyalty, maybe they are disloyal, and 4 to 5 is loyal. And then you are trying to see which of the other data variables will help me divide or put my consumers into a disloyal base or a loyal base. That's what discriminant analysis really does. If I were able to explain
And in fact, one more application, at least very quick application, which is used for discriminant analysis is sanctioning of bank loans. So what factors will you should use to say that he will repay that loan or not repay that loan? And so credit officers and analysis officers will actually look at some of those factors, will say that, okay, he's falls in a group where he will repay or he will not repay, and some of that is used by banks to actually sanction their loans or not.
Absolutely.
All right.
From a marketing
so if we may proceed.
Sorry, just a second.
So if we may proceed with cluster analysis. Thank you.
Okay. Next, we have a cluster analysis technique. Now, cluster analysis is used for segmentation. What are we talking about when we're talking about segmentation? Is basically trying to group customers based on similar needs and profile these segments. Now, when we do marketing, we cannot sell our products to every customer as is, because every customer has different needs. Now, how do we kind of group our entire set of customers into these different segments? That is where we use cluster analysis. So we know data about these consumers. We know they have certain attributes, like they are of a certain age, a certain income, they have certain preferences or liking, they have certain opinions. We collect this data from all the customers and then put that data into cluster analysis technique. And what that technique does is it segregates this data into segment of consumers. Now, these segment of consumers internally have similar kind of liking, attributes, etc. But one segment is very different from the other segment. One of the biggest differences that you have over here is that cluster analysis, we are dividing data based on the attributes. And in factor analysis, we are dividing the consumers into, you're trying to divide the attributes into separate groups. So they are two very, very different techniques per se. And let's understand that a little more here. So when we do segmentation, we are looking at each segment being identifiable, unique, substantial, and accessible, which is the basic thing that we want as a marketing person. Now, how do we identify what segments exist in my data? And what is the profile of these segments? And how big are these segments? So all of these answers will be given by this technique of cluster analysis. Okay. This is an example of what cluster analysis will help you find. Okay. Suppose there is this data of consumers. Now over here, as you see, these consumers pretty much look like the Simpsons family, if you've seen them. And these are some other people as well. Now this entire set of data, it is being segmented in two different ways. Okay. One set of segments is if we segment it basis whether they belong to the family or are school employees. So this is one segmentation way. Another way we could segment the same data is just by gender. So we put females together as one group and we put males together as one group, right? But all of this was not possible by, just on looking. If we put that data into cluster analysis, what cluster analysis will do is it will divide the data in such a way that it will put these people into one cluster and these people into one cluster. This is one way. If we use the segmentation base as gender, then it will divide the data in this particular way. And this label is unknown, right? So we will use your cluster analysis output to actually generate this entire label or to come up with this label name. right? So what cluster analysis really does is find similarities between the data according to these characteristics or attributes which are there of each respondent. And it will try and put respondents which are similar in terms of their ratings on a particular attribute into one particular segment versus people who have different ratings on those attributes into a different segment. Now, these different segments which come up will be very different in terms of their behavior on those attributes, right? So segment is nothing, but it is a collection of customers, okay? And this is a very big difference compared to factor analysis. In factor analysis, you are clubbing the attributes depending on the attributes being correlated to each other. Here, you are clubbing the customers depending on how they are rating on the attributes, right? So cluster analysis is more of grouping of respondents, whereas factor analysis is grouping of variables. Okay? This is one of the biggest differences between the two analyses. So it's a multivariate statistical technique. Now, again, there is no independent or dependent variable. We put all the data together, and it is applicable to data which is collected on continuous scales, categorical scales, and you can also do it together for categorical and continuous data. So you can have things like Likert scale ratings and also things like gender put into the same cluster analysis technique and segmented. So grouping is done basically post-survey data is collected and can be used to collect, cluster objects, individuals, and even entities. How it works is it measures the proximity between the variable ratings or the variable measures. Where it is used largely in customer segmentation for segmentation, which is based on various kind of variables like psychographics, usage reasons or perceptions or loyalty or demographics. It can also be used for B2B market segmentation, wherein the same kind of grouping principle will be applied for industrial consumers. I'm just talking here about a few examples of cluster analysis. First is retail marketing, which is suppose you have collected data on things like household income, size, household occupation, or distance from nearest urban area. You've collected this data. You will feed this data into the clustering algorithm, and perhaps the output will kind of cluster it into 4 clusters, which is small family high spenders or large family high spenders or small family low spenders, etc. It can segregate this data. And then you can use that understanding to send personalized advertisements or sales letters to each household based on how likely they are to respond to specific types of advertisements. Now, here is again a case of the same data that I used for understanding online clothing shopper, attributes. If I use the same data and I put it into the entire cluster analysis technique, this is a cluster output that I will get. Okay. Now, what this cluster output here shows is this is called the cluster centroids. Okay. This is the final output we use to interpret each of the clusters. So what this output is showing over here is there are 3 clusters into which I can divide my data. That means all these clothing shoppers can be segmented into 3 segments. Segment 1 has these kind of ratings on these particular attributes. For example, segment 1 is pretty negative in terms of the logistical ease or convenience or enjoyment which is associated with online shopping. They also are negative in terms of how interactive the website is or how informative it is. And they are also giving a negative score on visual engagement. Okay, so this is one segment. They're pretty negative about the entire online shopping dimensions. When you look at segment 2, they have a high positive score on inefficacy and distrust. That means they do not trust online shopping and they feel that they're not capable of doing online shopping. That is self-inefficacy. And then you see segment 3. Here, all the ratings are positive in terms of ease, convenience, enjoyment, interactivity, etc. But the first two areas, which is self-inefficacy or distrust, are negative, which means that they do not have any such issues on self-inefficacy or distrust, right? Now, based on these particular centroid scores, you come out with the names of these segments. So the first segment is what we name as averse online shoppers. That means they do not like online shopping. The second particular thing we talk about as convenience shoppers because they have a very high rating on convenience as compared to the other two clusters. The third segment that we come out is what we call as shopping optimists. They are very happy to shop online. They find everything about online shopping to be very good, right? So this is just the 3 segments that we have taken out. We also collect a lot of data in segmentation studies on profile of these consumers. And then once we get the clusters out, we are trying to figure out, do these clusters differ by age, occupation, income, and gender? And these are the 3 cluster data points. So we see over here that convenience drivers are largely people in the 25 to 34 age group. And averse online were actually people in the 18 to 24 age group, right? In terms of annual income, if you look at, what is the income size and what is the income range of people in each segment, what we find over here is that a large proportion of these online shopping optimists are people who are having higher income group, right? Similarly, in terms of gender, for convenience drivers, you largely have males as compared to females. In the other 2 segments, you have similar kind of male and female population. Now, we will get together all of this data and we will put down a final cluster solution or interpretation of these segments, right? The segmentation solution will also give you an idea of your market data is divided into what percentage is lying in each segment. So my averse online segment was 25%, online shopping optimists were 37%, and convenience drivers were 37.7%. Now this is how a marketing company will know how big is each of these segments, okay, based on the data that they collect. Next, we come down here and we put down all our interpretations. So we found that averse online shoppers were largely students with a lower education level. They had a lower internet usage and they accessed internet largely via smartphone. Their purchase frequency and amount spent across various categories of clothes was low. And 50% of them used cash on delivery as an option. And all of this data was collected in our survey. And the reasons why they still wanted to purchase online was the offers that they got, which is the discounts that they got, time saving and availability of certain sizes, which may not have been available to them offline. When we looked at convenience drivers, we had largely male people, 53% working class, married, low internet usage, and a large percentage of them use desktops. Highest percentage buy designer wear, right? And this also showed in the reason for their buying. So while they felt that online, e-commerce stores gave them a lot more easy access to fashion styles than they would probably get at those rates offline. And then online shopping optimists, they largely, were high income people, well educated, high use of internet across categories. They have a high purchase frequency, and they offer, the reasons for their purchase is offer deals and time saving. Now, as a marketing company, you will decide which of these segments you really want to target. And based on what reasons they want to buy or purchase online, you will have to look at whether you can offer them something like that. For example, here we talked about ours online shoppers. They said availability of sizes was one of the reasons which was there for them to still shop online despite the fact that they did not like shopping online, right? So if the company wants to target these kind of consumers, then probably they should give them a very good range of size of clothing wear, right? And public put advertisements which are there from that perspective, saying that we have a large availability of sizes here, because if you're looking at targeting the convenience drivers, then you need to first make sure that you highlight the factor of easy, convenient shopping online when you put your advertisements. And you also talk about fashion styles, of the fact that you can buy something online which is more fashionable versus what is available offline, right? So all of these right from factor analysis, I use those factor scores into my segmentation and cluster analysis. And therefore, I was able to come up with this entire segmentation study to understand what kind of segments exist in the market and how you can attract them. All right. Other examples there where you can use segmentation, for example, if you are having a streaming service like a Netflix, right? And you have this kind of data about minutes watched per day or total viewing sessions or number of unique shows viewed per month, then you can again use cluster analysis to identify high usage and low usage users. You can do that. Email marketing, if you're doing, for example, if you are sending a lot of emails to consumers and you have all this data around you with percentage of emails open, number of clicks, time spent, you can do cluster analysis to find out the types of emails and frequency of emails they can send to different clusters of customers, right? Or if you're into insurance marketing and you have a lot of data about households on number of doctor visits or household size or chronic conditions, etc., you can again feed this data into an algorithm of clustering and come out with different monthly insurance premiums, etc., that you have to do. Cluster analysis can also be used beyond marketing into things like career planning and training analysis to understand what kind of segments exist in the market and or in the company, and how you want to really target those, or which of those you want to really target. Again, you also segment your financial sector or instruments industry, also can use clustering techniques. So cluster analysis pretty much can be applied across a wide range of industries to understand what are the segments which are existing in the market and how to target them. I am not really going through the cluster analysis technique because that's a very long technique as in, but I just wanted to give you an understanding of how cluster analysis really is used. And I am open to questions now.
Yeah, so any questions? Any questions from the students?
No, ma'am.
Okay, great. All right. So if we can have Chetna, please. Chetna, can you deliver the vote of
Excuse me,
thanks?
ma'am. Excuse me,
Yeah,
ma'am.
Anika.
Ma'am, Professor Atul has dropped a message in the chat. He has a few questions to ask.
Yes, please. Sorry, I can't see the chat here. You can read out, Neerja.
Yeah, so he says, recent paper suggests taking eigenvalues apart from greater than as significant apart from greater than one. One of the most accepted technique nowadays for finding significant number of eigenvalues is parallel analysis. In past 2 decades, there has been research that shows that principal component is not considered to be a good factor method for factor analysis. orthogonal rotation is
Yes.
used in
That is
specific circumstances. Yeah.
Yes, you can use either of the techniques. It all depends on what kind of conditions you're using, but both can be used for factor analysis. Principal component is largely used for data which is pretty normal in nature, and it is also accepted as a technique, but definitely you can use orthogonal rotation as well.
All right. Okay. All right. Chetna, any other questions from the students? Otherwise, Chetna, can we have you please delivering the vote of thanks? Yeah.
Yes. Good evening, Shweta ma'am. First of all, to be honest, it's a lot to absorb for the first time.
I understand.
There are students here who are from non-commerce backgrounds and non-stats background, and I'm one of them. So I would like to start my vote of thanks with your quotation itself, when you said that research is what others do not see, and then finding that something for myself. Thank you for explaining what research and marketing means, as we are in the last leg of our first year and soon we have to pick up our majors in the second year. I'm sure this will help us immensely, because marketing and analytics is going to be a good combination. When we usually hear about research, we think it's a very geeky 9-to-5 mundane desk job. But today I think the perception must have changed a lot. It should have taken a U-turn. Marketing in itself is innovative. We have to be quick and on the front foot every time. And relating it to research will only make it faster and more creative. I think this holds true for the business world altogether. And with technology getting integrated into our lives every day, research will help us gauge the changing face of market in the coming times. So I would like to thank you for sparing your time for us. We learned a lot today, definitely. And I would like to end the session with a quotation from Mahatma Gandhi. I think it's best the situation. I quote, "Live as if you were to die tomorrow and learn as if you were to live forever." Thank you so much, ma'am.
Thank you. Thank you so much for this opportunity. And I know it is too much to absorb at one go, but look at the gist of, using these techniques, not really the process so much, because process you can always learn as you go along. And once you do it, it will be easy. But, application is more important where it is used. Thank you, Dr. Nivisha, for inviting me over. And I really enjoyed.
One second. Yeah, 1 second. So Neeraj, if you can just, as a thing of gratitude, we'd like to present with you to you a memento. Of course, now we'll have to do it virtually for you, and then we'll maybe whenever we meet, whenever you come over to Delhi, then I'll personally pass it over to you.
Oh,
yeah,
thank you so much.
All right. Thank you so much, Dr. Shweta, for agreeing to address the students, giving them into this market research, this whole full area. Of course, we've gone a little fast, and they in their
yeah, thank you so much as well. I really enjoyed the entire session, and I hope you got something out of the session overall.
All right. Thank you so much again, Shweta.
Okay. Bye-bye.
All right.